soccer game, we'd be kind of in the, what do they call it, injury time. We'd be in bonus time at the end, trying to avoid a shootout. Um, so let's see what we got here. I'm speaking on behalf of Ben Bussey of HEOMD, and on behalf of other members of the group here that put these SKGs together. Let's see. So, okay, what are SKGs? We've mentioned strategic knowledge gaps a few times in a few different contexts over the last couple days. Basically, as you might guess from the name, it's the gap between what you need to know and what you actually do know. So this is something that I think Mark Wargo was the first time I heard the term used. Although it's something that you find in management literature. And we're kind of taking as our axiom that we're going to send people to Phobos and Deimos. This is not a policy statement, certainly not a policy statement by me or anyone at NASA, but our charter was assume that people are going to go there. How do we get them there safely? What do we not know that we need to know? And ultimately, the plan would be to generate lists of measurements that allow people interested in the problem to go through and go, okay, I can make that measurement. I already have made that measurement, and knock those off. So if we look at some early attempts at spaceflight and human, well, sort of human exploration, you can come up with some examples of what these SKGs might look like. You can't really blame Ben for these slides. These are my slides. But basically, you can imagine, you know, if your exploration goal is you want to make sure that some form of Kryptonian life survives the imminent destruction of your planet, and so you decide the path is you're gonna evacuate at least someone from Krypton to make sure that your civilization survives. You can imagine some of the strategic knowledge gaps that you might want to know. How many planets are within reach of your little spacecraft that you can, you know, that can host Kryptonian life. Do you have to go to a K or an M star like Krypton has, or what happens if you go to a planet with a G star? What's first contact going to be like? How are people going to react to this kind of life? So those are kind of in the spirit of SKGs. During this past year, we've been focusing on updating the SKGs and publishing them. There was an earlier round that Mike Wargo asked us to do. That was developed through both SBAG and MEPAG, so both the small bodies community and the Mars community together. This round, we also included both small bodies and Mars folks, and also explicitly included Survey. I guess Survey didn't exist at the time that we first put these together. And so Survey folks have been involved in, I don't know how you put it. I was going to say managing. I don't know if that's quite right, but doing a lot of logistical work and managing the effort. The ultimate goal, we're not quite there, is to have all of the SKGs on the web in a fully searchable manner so that, again, researchers can go and say, which of these am I interested in? Which of these do we think we can tackle? Which of these are you know, not included that we think are important? So here's the team that I'm representing today. I'm the SBAG representative. Scott Anderson was appointed, so to speak, by MEPAG or asked by MEPAG to take part. Brad and Greg from Survey. Ben did not put himself on this slide, but Ben is sort of the overall HEOMD contact who's been leading us through this effort. And then the members of the special action team, at least two of whom are in the room right now, Paul Abel, Julie Belrose, Julie Castillo-Roge, Barbara Cohen, Christine Hartzell, Pascal, and Brad Thompson. So representing a range of expertise across small bodies, Mars, Phobos and Deimos, geophysics, astronomy, etc. So our charter, so what we were asked by Ben to do, is to review the list of SKGs that already existed from the previous round, and kind of see if recent observations have retired any of them or generated any new ones. Identify, again, any new SKGs. Review the measurements that we would need to actually retire these risks. So not just map the surface, but map the surface to some particular resolution in some color or colors if appropriate. And then consider, here it says the venue, priority, and timeline. That's just a fancy way of saying, can we do this from flybys? Can we do this from orbit? Can we do this? Do we have to land? Do we have to do a sample return? Is this the sort of thing that can be done just with simulations on our laptops or at home? Priority and timeline, again, kind of speak for themselves, whether things are nice to haves or really critical. And again, this just kind of was what was used in the past. Some things can be done simply with RNA if you're willing to fund or support some modeling efforts that can be done. Earth-based, that's speaks for itself there too, whether it's ground-based telescopes or some equipment in a lab, whether some kind of radiation studies could be done here on Earth. International Space Station is included. That's an asset that human exploration has access to, and there are some studies that only need microgravity, and that could be done there. And then again, robotic missions, whether flyby or et cetera. In terms of priorities, I think we actually use a different, no, maybe we don't use a different list for this. Critical here means you can't go ahead, you can't ethically go ahead without figuring this out. High is important for maximizing human safety, but maybe not formally needed exactly. And then enhancing would be one of these nice to haves. For time frame, near, medium, and long, these are kind of at this point necessarily a bit vague, but at least we have an order that you have to do this one before you do that one, before you do that one. We are not, we have some ideas for these, for the SKGs. We don't necessarily have the final word on these. There's been a lot of discussion back and forth as to whether we would even consider something enhancing to be an SKG in the formal sense. If something is just a nice to have, does that mean that it's not technically an SKG? So we have some examples, but I think I have the actual list here. I have at this point, I have a slide for each one, and we can go through that. I'm happy to do that. I'm happy to just discuss this list that's sitting up here in slightly less detail. Ben was not thinking that this would necessarily be a place where we would discuss and generate new SKGs, but on the other hand, this is clearly a community that's interested in this. The at least medium-term plan is that we will have a website with an email address where people can send in their suggestions, their discussion, either saying, look, we've already done this, or look, you haven't thought about this. But right now, these are our categories. We have a group that is, I guess I'm going to cheat here, a group that is under this theme of surface mapping, that deal with surface composition, human health and performance, surface topography. Actually, why don't I just go through one by one? Yeah. You guys are dead. You guys really are tired. There's one of these 0-0 soccer games up here. Okay, so first, mineralogical and chemical composition. All of these slides we separate, each SKG has an identifier. The first letter is the theme. That second digit there is a category, and then the third one is kind of the unique identifier. So the first theme is surface mapping. We have several in surface composition. The idea is that we want to determine which parts of Phobos and Deimos to explore, so that we can do as much planning ahead of time as we can, do these kinds of EVA planning that were discussed a little earlier. We would want to do measurements like understand where the major geologic units are on Phobos and Deimos, so that from a science point of view, you can visit as many of them as you think is appropriate. We'd also want to understand the ISRU potential, which again could help determine where we would go. We think that at least potentially you could do this a few different ways. This seems like a medium priority, but something that we'd want to do early. As I noted, this is still a work in progress in a sense. So while in earlier slides we were talking about kind of the specific measurements, we still have in some cases work to do to talk about what resolution we need to do this to.
And why is it medium?
That is, we could send people there without closing this.
I'm thinking in Apollo we had maps before we sent people.
Yes, and we have some maps now for Phobos. I mean, admittedly, this is a little squishy at this point, but this was not as obviously, look, you can't possibly do it. You could imagine putting in a period of, if you have 500 days there, you could imagine putting in a period of reconnaissance where they would do it at the time. But well, like I said, this is a work still in progress, and we're given a.
Sorry, can I chime in? So, Carly, I was still a little boy during Apollo, but my understanding is that we didn't actually know what lunar rocks were made of until we had Apollo 11, right?
No, but we had geologic mapping.
Sure, we had guessing of what was there.
That required information about the surface and its very detail, especially for the landing sites.
We also had surveyor analysis.
Yeah, we had surveyor in situ analysis for sure.
Yeah, I think another part of the problem, just in terms of doing this, is that there was one iteration, where everything's high. And if everything is high, then that doesn't do you any good either. So,
But
We're just on the first one.
but even,
that's right, the first of like 150. So we'll take our time here. And
sorry, but even in the case of surveyor, my understanding is that the priority wasn't technically the science, it was sort of the geotechnical properties of the surface. It was to certify that the lunar module will not be sinking into the regolith. That was sort of the issue that was being addressed by the surveyor that cleared the way to Apollo.
That's true, but there were geochemical instruments on there specifically to look at the composition, for sure. All right.
so, but that's a good point. So we've broken finally in some cases. So it's possible that what you think is the high priority part of this will show up in one of the next ones. So this is similar to the first one. This is elemental composition instead of mineral composition. Then we get into toxicity. So I don't seem to have a narrative for this one, but basically figuring out what the toxicity of the components of the surface of Phobos are. And this one gets divided into, I think, both chemical and physical toxicity. So is it poisonous, and then is it going to, be like asbestos and not actually be literally poisonous in that sense, but scratch up, kill you anyway. These are high priority. These we didn't necessarily think that we could do until a medium or long term. But this is more clearly something that we would need to figure out before we put people down. Especially if we think that these are cohesive materials and could tag along into the habitats. So this is the second one, physical toxicity, again, physical characterization. This we also would consider a high high priority. So this is separate from, hey, is this forsterite or is it phaolite, which is less of a concern from that point of view. Surface topography is its own. This is for understanding the mobility, how difficult it is to, how much kind of propellant and delta V you're going to spend maneuvering around. This one we think would need a global shape model. Again, we think we could do this one relatively soon. And this one we consider a high priority. Then there's the second theme of surface and proximity operations. We have a set of them that are related to radiation and plasma. I should also say, there was Ariel's talk earlier, and we have not yet gotten kind of together. We haven't looked at that to see how that might help inform some of these, to see that we're all kind of, that's an independent take on in a sense, on these SKGs. So we certainly should compare notes on that. So for this is determine the surface radiation environment. We'd want to measure the dose you'd expect from cosmic rays, et cetera. That's also high priority that we think would not require anything other than a measurement at the right place. We separate that from the surface radiation environment. The previous one was radiation environment in orbit. This one, we would want to have something landed to measure the radiation dose on the surface, and whether that changes, how that changes with location. So that's the sort of stuff that Bill Farrell's team was looking at, for instance, with the environment inside and outside craters. This would, I guess it wouldn't exactly be that. Yeah.
You know, we definitely separate radiation from the plasma. But what we do in radiation is we actually separate the solar energetic particles from the galactic cosmic rays. The galactic cosmic rays, you definitely want something measuring dose. But for the solar energetic particles, we actually talked about getting like an early warning system, you know, in place. And that was a high priority. We call that enabling. Because, you know, in Apollo, they just missed the August 72 solar storm. If they had been out and not in that solar storm, that would have been quite, it would have been probably a problem. So
that was in that Michener novel, wasn't it?
What's that?
Wasn't there a Michener novel that had, space? Yeah, 19. Yeah.
So you saw those CMEs, right? You know, we talked about that active regions on the sun. What you almost want is a dedicated spacecraft to look for active regions to tell you a quarter of a solar rotation that you've got an active region rotating around. Now, for the Earth-Moon system, that's, you know, you put it out at L5. For Mars, you may need something a little different. Anyway, we should talk because the format of ours we should try to get them to look the same.
Yeah.
You know, in the lunar and the Phobos one.
Yeah, I know that's on Ben's to-do list. Yeah.
And Bill, I was going to add that this is very much an issue with a number of SKGs. So, are you saying this was in the revision, the one that was just done by League?
We actually had it in before in the 2012 version, the separation of GCRs from solar energetic particles, because how you handle them is a little differently. And it's not just getting the dose. You know, we actually were talking about preventative measures. We get out, or at least something to tell you to give you a watch, which is something looking for active regions, and then an SEP warning system. So it's almost like tornadoes, tornado watch and tornado warning sort of thing.
Yep. So we'll continue to march through. This is more the stuff that you guys talked about: surface fields, plasma in proximity to the surface, dusty plasma effects. Gravitational fields, again, we'd want to know this for planning operations. Here here the thought is that getting the spherical harmonic terms of the gravitational fields are what we want. Orbital debris hazard. So this would also be where Pascal's extra moons of Mars would fall. Although we mostly were thinking of the potential material due to dust, or the potential dust between Phobos and Deimos. We've had, and Pascal was part of these discussions, we're still batting around how big of a deal this is. It's there. How much of a hazard is it really if it's not moving terribly fast relative to the spacecraft? But we do still accept that it's a thing. It's just a matter of what the priority is in terms of closing that.
Your comments just struck me as, the classic way of doing missions with probability of likelihood versus risk. And did you include any of those, or was it just one answer? In other words, in this case, the probability of there being dust is low based on the data we have. But if there is something there that's going to whack a spacecraft, its impact is high.
Yeah, we haven't thought about it.
Okay, so it doesn't matter the probability.
I think part of the problem is that we don't necessarily know how you would do that in the consequence likelihood space. That's the gap, right? The gap is.
That has a gradient that's high, medium, low, no, I understand that's why it's an SKG. It's what the priority is.
So we could work that in making I think in making a decision to invest in something, we would have an idea of the relative importance of the data to design the human system that's going to need it, right? So we can do that risk analysis when we get there for it. Okay, so these were a qualitative ranking to get that, but we can certainly refine it when we need to, in terms of the tall poles in the tent, the absolutely critical.
What you're saying then is whatever the priority assignment is here is not linked to the risk analysis. That's what I'm having.
It's linked to a qualitative risk analysis that is more based on the cost, the word just went right out of my head. What we're doing is the SKGs reduce the amount of over-engineering you have to do. It's how you manage your risks. We don't know the detailed gravitational field, so we're going to design this system to handle, everything, which can add considerably to the cost, complexity of the system. But if we decide that that's the barrier, then we need to go get that data, and then we can refine the actual system design, thereby reducing the cost and improving the risk. I feel I babbled, but I hope you got it.
No, thank you. So yeah, I got flashed a yellow card, so we need to sprint to the finish here. Again, just to flash through these, regolith particle size frequency distribution we think would affect the mechanical systems potentially. There's a lot of fine material. The geotechnical properties are going to be really important. The density, compressibility, etc. Cohesion is clearly going to be important. Again, our astronauts going to go out there and get immediately covered with cohering material and then go back inside and then all choke to death. I don't know. That's part of the reason we need to know this. Are you going to be able to scoop effectively, or are you going to be able to anchor effectively? Upper surface stratigraphy, again, this is an anchoring issue, and clearly we're going to need to anchor things, especially if we're afraid we're going to, Dan Shears is going to have them trip and fall and fly into space. Surface boulder distribution to determine block hazard. How much room do you have to land? How small do your landing ellipses have to be before you're kind of sure that you're not going to hit something? So we need the size distribution of surface boulders. Excuse me. Macro porosity, again, this would be understanding mass movement hazards. How likely are you to cause a landslide? How much material is kind of how in place material is. That's not a very good way to put it. But if you put down a surface asset, if you anchor something, are you going to cause some landslide, basically? Thermal environment, this basically will tell you how much of a temperature swing your mechanical systems are going to have to deal with. And again, it could vary with depth, so if you're anchoring stuff, you might end up with thermal gradients in your systems. Home stretch here, volatile distribution. This is important for ISRU kinds of questions. The whole ISRU question is one we're, again, wrestling with at a top level. If there were no volatiles on Phobos at all, would that stop you from sending people? If we didn't know, would that stop you from sending people? And there are varying opinions and varying strengths of those opinions. So again, we have a kind of a TBD here while we sort that out. This is more of the same, just instead of distribution, it's concentration. And then the form, is it ice? Almost, it's probably not ice, but, deep subsurface ice, probably not, but, formally rule that out. Is it OH at the surface? Is it OH in clays, or is it some kind of OH that's formed from hydrogen implantation? There's volatile extraction, knowing how to extract the resource, again, whether this is necessarily an SKG that we should be carrying versus kind of an engineering issue is not necessarily clear. And then the last one, reverse planetary protection. Are we going to, this is a bit of a stretch, maybe. Could life from Mars end up on Phobos and then be brought back to Earth? I think we all recognize this is something of a long shot. This is also one that we think could be worked out just with a grant and some math. So basically, the thought is, if you did have life on Mars, what kind of conditions would it experience getting up to Phobos? How long could it actually last? Oops, looks like I hit the button. Again, next steps, we're looking to finalize the SKGs we have, put them online, and then kind of let them loose. We're planning to put a contact address along with these, so that if people have work that has closed any of these, we can know that and cross it off. Or if someone says, hey, here's a good one you haven't thought about. Hey, I'm Bill Farrell, and here's what you didn't think about. Only Bill Farrell could say I'm Bill Farrell, though. And we would include that. And then continue to keep this updated in coming years as more research gets done that either close things off or comes up with new issues. I think that is my last, yes, that is my last one. So thank you.
Thanks, Andy. We have a few minutes that we can take for discussion or questions.